All right, guys, here we are. It's Miss Johnson, and we are talking today about our 6-2 notes, which are on operations with polynomials. So, second notes video of chapter 6. Our first example talks about Shelley, and she's searching for a college that she wants to go to. She's most interested in Southwest Minnesota State University, where the current year's tuition is $3,872. She assumes that tuition will increase at a rate of 6% per year, and then we need to express this after X years. So what we need to do is we need to take the current tuition, $3,872, and to that we need to add 6% of that, which is 0.06 times the $3,872 times the X number of years. Okay, and then if we simplify that, multiplying the 0.06 times $3,872, that's 3,872 plus 232 and 32 cents times each number of years. So that's a polynomial that will express the current tuition that Shelley would have to pay as the years increase. Now let's talk about a degree of a polynomial for a second. A degree of a polynomial is the value of the largest exponent or the sum of the exponents of the monomial. Okay, so if I look at those three examples there, v to the 5th power has a degree of 5. Okay, because that's the value of the only exponent, so it has to be the largest exponent as well. In part B, the degree there, if I look at my powers, I have a power of 3, I have a power of 2, and I have a power of 0. Okay, so my largest exponent there is 3, which means this is a degree 3 polynomial. Now in part C, there's 2 variables in one of the terms right here. So I have to add those 2 together. That's what it means when it says sum of the exponents. Since there's 2 variables in that one term, I take 7 plus 4 and I have 11. This term only has a degree of 1, so my degree here, I have a degree 11 polynomial. Okay, so that's just looking at the degree. So if we take a look at number 1, we have 1/6 times x to the 3rd y to the 5th minus 9x to the 4th. And we want to identify the degree. So again, we need to look at the degree of each term. So in this case, I have 2 variables. I need to take 3 plus 5. So there my degree is 8. Here I only have 1 variable. My degree is 4. So the degree of the whole polynomial is the largest one, which is 8. Now I want you to pause the video at this point and see if you can tell me the degree in number 2. Let's just review some operations with polynomials and see what they look like. When we add polynomials, we want to combine their like terms. So we're looking for terms that have the same variable part. That's what like terms are, in case you forgot. Okay, same variable part. When we subtract them, we have to distribute that subtraction. We're going to add the opposite. So the subtraction is going to go all the way through the polynomial behind it, and we're going to add the opposite. Then combine the like terms, just like we did with addition. And then with multiplication, we need to distribute each term in the first polynomial to each term in the second polynomial, and then combine the like terms. Now remember, throughout any of these videos, you can pause at any time that you need. So if you need to take a minute and write all of this down, go ahead and pause the video and we will be moving on. Let's take a look at number 3. We want to simplify the expression. In number 3, I have 3x squared minus 2x plus 3 minus x squared plus 4x minus 2. So if I add the opposite, that means I'm going to be adding everything behind it, but I have to take the opposite of everything behind it. So this x squared is going to be negative x squared. This 4x is going to be negative 4x. And that 2 is going to be positive 2. And now I just look for my like terms. Remember that like terms have the same variable part. So here I have a 3x squared. There I have a negative x squared. 3 minus 1 is 2x squared. There I have a negative 2x. There I have a negative 4x. That's going to be negative 6x. There I have a positive 3 constant. There I have a positive 2 constant. Adding those together, I get a 5. So then I can check my simplification. I should see each variable only one time. I do. It also should be in standard form, meaning the largest exponent is first and we decrease from there. And it is. So there's nothing else that I can do to simplify that. Let's take a look at number 4. And number 4, now we're adding the polynomials. So all I need to do here is combine my like terms. Okay, combine the like terms. Nothing to change in the polynomial behind it. So I'm just going to look for my common variables. I have a 5x squared and negative 3x squared. 5 minus 3 is 2, so that's 2x squared. I also have negative 4x and x. Negative 4 plus 1 is negative 3, so that's minus 3x. And then I have a constant of 1 and a constant of negative 3. 1 minus 3 is negative 2. And then I can check my polynomial. I see each type of variable only one time. I have x squared, then x, then a constant. I also have it in standard form because I've decreased my exponents. Nothing else I can do to simplify, so that's it. Okay, let's do one more together in number 5. Number 5 is back to subtraction. So again, I need to distribute that subtraction to everything behind it. So I am going to add the opposite, meaning that's going to be addition, and everything behind it is going to be the opposite. So that's subtraction, that's negative, that's negative. Okay, and now I combine my like terms. So I have a negative x squared and another negative x squared. That's negative 2x squared. Then I have negative 3x and negative 2x. That's negative 5x. And I have 4 minus 5, which is negative 1. Negative 2x squared minus 5x minus 1. I want you to pause the video at this time and see if you can work on number 6 on your own. Now let's flip it over to the back and take a look at a couple examples there. Now I'm looking at multiplying. So I have a monomial outside. I have 2x on the outside, and I'm going to distribute that through to the inside. So take the 2x, multiply by every term that's behind it. Okay, I have 2x times 7x squared. I multiply the coefficients. 2 times 7 is 14. X times x squared, add my powers, which is what we talked about in our video yesterday, x to the third. For the second one, 2 times negative 3 is negative 6. X times x is x squared. And for the third one, 2 times 5 is 10. And x times no other x is just x. Check to make sure if you have any simplification, which in this case we don't, and I'm already written in standard form, so that's all I need to worry about there. I want you to go ahead and work on number 8 on your own, please. And that's going to be the end of our video for today. So thanks for watching. Don't forget to go back to Schoology and take your Schoology quiz. And I will see you all tomorrow.